Welcome everyone. I want to tell you first of all how excited I am, how refreshing it is to look out and see women and tech fields in our audience. And I want to thank you men for being here as well. I'm happy to see you too. So the first thing I want to ask, I'm going to start with a poll. How many people here have lost productivity, days, weeks, a lot of time, because you've been trying to track down a bug, recovering code that you've lost, or even just trying to understand code that you wrote last month? Okay, thank you. That was a lot of hands. Second question, how many of you consider yourselves software developers? Not so many hands. All right, newsflash. If you write code, you are a software developer. Even if you're the only user of your software, it is software. People who use programming as a tool tend to not view it as a product. They tend to view it as just a casual tool that they use and don't really think about it as software. So I'm going to talk today about some problems that appear when you don't treat your software like code, and how some basic software development principles and tools can help you be more productive and more effective. So my target audience here is people who code but didn't raise their hand for the second question, don't consider themselves software developers. If you've worked on a large software development team, have a computer science degree, this may not be the ideal talk for you, and you're welcome to jet out of here for another talk. It won't hurt my feelings. If you don't have a lot of experience in code, that's okay. This is not, it's a technical topic, but not technical content. So I will step you through just a high-level introduction to principles and tools and some resources to learn more. So I'm going to start off with my own story. My first job was as a surface-to-air missile analyst. It was a modeling and simulation job. I worked on a physics model of radar performance and missile trajectory. It involved a lot of coding. I was creating run scripts, I was configuring input files, I was modifying my simulation code, post-processing data, producing data visualization, all of those things. On a regular basis, I probably used 4 different computer programming languages, but I wouldn't raise my hand, nor would anyone else on our team. We weren't software engineers or software developers. So our product was the analysis. It was a report, it was a briefing, it was a table, data. It wasn't the software. So it was a pretty fast-paced job. We had a quick turnaround for a lot of projects, so we took a lot of shortcuts, right? We hard-coded our data. We made changes by putting files on the shared drive. We didn't test things, instead we just prayed. And overall, we just relied on the brilliance of the team to make up for these things. And it usually worked. It was a team of rocket scientists. But we ran into all kinds of stupid problems from really smart people. We had our aircraft flying backwards in the simulation. We presented the wrong data. We panicked and had last-minute rerunning of huge analyses. And then we would run out of time for the really important step of turning our data into a story so that we can communicate a message to our audience. And in the end, it impacted our credibility, but more importantly, we didn't accomplish our job, which was impacting the audience decision-making. So I'm going to introduce you to just a handful of tools and concepts. There's lots more, but I'll just give you some starting points. We won't cover everything in the field of software development, believe it or not. So you might wonder, why? Why do we do this to ourselves? Why do we not use software development tools as coders, scientists, analysts? Well, the big thing is training. Scientists, analysts tend to be self-taught or taught by other analysts, taught by someone on the internet. And so they just don't know that these tools are out there. They don't know how to make things better. There's also a significant problem sometimes with imposter syndrome because you don't consider yourself a software developer because you don't have the right background and you're maybe intimidated by people that you view as real computer scientists. So it's easier to say, well, I'm just an analyst, and not claim those skills. It requires a lot of investment of time and money to learn these tools and to procure them. And it's hard to believe sometimes that it will be worth the investment. And that's kind of based on the very false belief that you're not going to make that same stupid mistake next time. And I'm here to tell you, you are. Or someone on your team is. So how do we fix this? Well, awareness and continuous learning are really the best solution. There's nothing tricky about these tools and processes. For me, a big thing was a mentor who was willing to call me out on bad practices and point me to resources that would help me to improve. Dealing with the imposter syndrome, it's time to own up to your role. Don't be intimidated. The people around you don't know more than you. My next job I had the role, my job title was principal software engineer. And so I had this moment where I said, now's the time, I need to step up. If that's going to be in my job title, I need to educate myself. And the next job the pace was a little bit slower. So I had time to implement best practices and to get up to speed with some of those tools. So like I said, I'm going to first step you through some tools. And the way I'm going to structure this is I'm going to introduce a software or a coding problem that many of you have probably experienced. I certainly have. And then we'll talk about a solution to it. So the first one, you have a tiny bug in your code, and it shows up at the worst time. It's when you have something better to be doing than debugging code. You have a deadline, you're supposed to be doing analysis, you're not supposed to be fixing something that you or someone else wrote weeks ago. So the solution is to test your software before it's time to do analysis. The best software testing is code that tests other code. So you write automated tests, and then you can run them. You write it simultaneously with your code, and you want to do that before you start your analysis. There are a number of different tests. I'm going to cover a few of them very briefly, not all of them, but there's certainly more. You can test to your heart's content all day. But the first is unit testing, and that's testing small units of your code, such as functions. You want to test edge cases and invalid data, and make sure that your program isn't going to crash from something like that, or that it appropriately reports an error. To do this thoroughly, you may have to change how you code, but you may have to think more about how you write your code, but you'll save time in the long run because you won't be tracking down bugs when you're supposed to be doing analysis. A really good resource for that is a book called Introduction to Test-Driven Development by Kent Beck. And if you want to dig in a little bit deeper to that, I highly recommend that. There are testing frameworks out there that are language specific. There is something called RUnit if you're using R. I frequently use G-Test, Google Test, for C++. And so this is a really simple example. This function takes two vectors that each represent an XY coordinate in space, and it just returns the distance between them. The test, written here, tests three different numeric types, and it compares the output to a hard-coded value, which was produced with an outside source. So it was maybe done with Excel or a calculator, computed offhand, not with the function. It tests zero values and negative numbers. Can anyone think of additional tests you might want to throw in there to make this a little more robust? You could also test for invalid data, or maybe for 2 points that are the same, which is going to return a 0 to make sure there aren't any divide by zeros in there. You could keep testing all day, but you probably have a job to do. So you'll move on to your verification and validation testing. So verification testing is that your code is working as you designed it. So you'll probably compare it to your team's own documentation of how you design the software and how you expect it to behave. Validation, on the other hand, is validating that the code is designed correctly so that your team's design matches, so that the algorithms are, for example, physically correct. So you want to compare that data to an outside source, usually. Something I'm a big proponent of and I never see is validation of your data visualization. We tend to think that we have a good feel for things if they look right, especially if they look like what we want our results to look like, then it must be right. Well, I can't tell you how many times I have seen that be wrong because of some bug in your code. So my recommendation is to produce a synthetic data set where you know exactly what the plot is, and maybe have a set that you use over and over again. Every time you make a change, take a look at the data, plot it. It can be something as simple as this plot is going to look like a circle, or it's going to be all one color for my contour plot. So don't make it hard, just make it obvious. Other testing you might do that I'm not going to go into: integration testing, making sure all your pieces work together as a whole. There's also user testing, which even if you are the user, sometimes it's good to have someone else step in and use your software because fresh eyes will see new things that you've been staring at for months so that you don't even see it anymore. So the next coding problem is the reappearing bug. I fixed this already. Why is it back? It's Joe's fault. Because he gave me that new version of that algorithm. Now where was the fix before I got Joe's code? So the solution, version control. So version control manages different versions of your files. It archives your old files. It helps you to merge your changes so that you can collaborate with teammates. The most common example is Git. You can also use things like Microsoft Team Foundation Server or Subversion. If you've never used version control before, even if you just have one file that you are working on by yourself, I highly recommend it. Download Git, it's free, it's very well documented, there are tons of tutorials out there, and it's really popular. It looks great on your resume. You should definitely try it out. So we're going to switch to concepts now, still addressing our problems. So the example here is that you're going to sit down and hack at your problem without a real plan. You're the only one that knows what's going on, so you don't know where you're going with it. You're just going to dive in. Well, the industry uses something called the software development lifecycle, and that revolves around designing, developing, and testing software. It improves quality. It's not exactly a methodology, but more a description of the phases of software development. It pulls in multiple stakeholders so that you're not just sitting there trying to figure it out on your own, but you have everyone who's involved can give you their opinion. There are kind of a couple of different methodologies and versions of how you implement this. A common one you'll see is the waterfall you've probably heard of, where everything is very sequential and it flows in one direction. It's not iterative, it's not real flexible. It's the more traditional model. It's not good to have changes late in the game. That's bad news if you're using the waterfall model. An alternative is the spiral model, which is risk-driven, and you start with a basic prototype, and then in phases, which are called spirals, you gradually add features and functionality, and that's to reduce risk, so that you have something that works for each phase. It's more iterative, and it's possible that your development may be less efficient because you're reducing your risk. Another very common, probably the most common methodology is agile software development. And this works really well for analytics, especially if you are the user, the developer is the user. It's very iterative. Your requirements and your solutions evolve through collaboration. It's evolutionary. A lot of features of Agile actually naturally evolve in teams of analysts. It's highly dependent on the idea of refactoring. It can be frustrating to some developers because you're rewriting your code and your requirements change constantly. It's like trying to hit a moving target. So I'm not going to go over the Agile Manifesto. This is kind of the 12 points. I highly recommend, if you've never read it, even if you're not an Agile kind of person, check it out. Think about the ideas. There are lots and lots of resources out there about Agile. So a really common bug is when you have lines of software, or lines of code that are the same, so you're going to copy it and paste it, and then make the change. You're going to change the variable name. But it turns out people are really terrible at doing this. It seems so easy. It's so tempting. Can you guys find the mistake? It's the it's the now I don't remember them. See, it's so hard to find. That's the problem, is that you stare at it even though you did it intentionally. So the solution is a principle called don't repeat yourself, sometimes referred to as DRY or dry, and that's exactly what it sounds like. Don't copy and paste. If you can avoid it, create a function. It'll reduce your mistakes. It'll make your code more readable. It'll be easier to maintain, and it is more efficient over time. You might have to think about it a little bit more, but you'll save time in the long run. So you have a really common problem that everyone has solved on their own in different ways. And some solutions are good, some are bad. None of them are perfect for you. Should you write a new one? How do you choose? Well, there's something called design patterns. And those are reusable solutions to commonly occurring software engineering problems. There's a famous book that made them famous. It's called Design Patterns, Elements of Reusable Object-Oriented Software. It's written by some gentleman known as the Gang of Four. And it's 23 classic software design patterns. Some of them are simple and obvious. Others are a little bit more complicated and clever. They're primarily based on object-oriented programming. The book is, but a lot of the concepts carry over. So this example here is what's called the singleton pattern, and it's just a way to make sure that you only have one copy of an object in your entire program. So I used it for a random number generator because I didn't want multiple RNGs. Another use for it is a logger. You don't want more than one logger. There's also something called anti-patterns, and those are inefficient, ineffective, risky patterns that people tend to use. They can be called patterns of failure. One example of those is the God object, which means all operations are performed on one object or in one function. So another problem you might see, you've written code to do this already. It's somewhere. It's not really going to be exactly what you need. It's the same idea. Even if you can find it, you're going to have to make modifications to it for the new project. So the solution is to write your code with modularity. Separate your functionality into different objects or different functions and avoid the God object. Don't put everything in your main code, your main.cpp. Set it up so that you can reuse the same things across projects. store it in a common directory that you can include in your files. Don't repeat yourself. Name things appropriately so that you can find them later. Long names are a good thing. So this is something I came across over and over again. I needed to do something quickly, so I did it the easy way, even though it's the ugly way, because I needed to get things done. So this is actually the worldwide premiere of what I call the cinnamon axiom, and that is you will never do something once. And this is kind of a summary of my career. Brute force is never the way to go. It's worth the time to think things through and do things right the first time, even when you think it's a one-off task. Problems repeat themselves, customers come back, projects come back with new names, and things never really go away. When it does come back, you won't remember the process you used for your brute force method, and you'll have to do it all over again, starting from scratch. So automate everything. You're writing code, write it for everything, use descriptive file names so you can find it later, and use version control. Use modularization so that you can use it for other things. So I really started seeing the benefits of these tools and resources when I became a leader of a team of software developers. It reduced the amount of turnover on a team, and it really helped with, when there was turnover, for transitions between people. Not taking shortcuts saves time in the long run. It allows you to spend time not just on completing your analysis, but crafting your results into a message. It improves your credibility and consistency. As with our team, we were rewarded for that by being trusted consultants and advisors for our clients. It had a positive impact on our project, and not only did we help people improve their designs, but we saw improvements on a bigger scale where these development engineers kind of shifted from this try and test and kind of guess and test method of designing things to thinking about things analytically the way our team was doing. So now that you have a pretty solid awareness of all these tools and best practices, I have some resources you can refer back to, and hopefully you can use it to become an influencer at your own job. So this might be a good slide to take a picture with your phone. A number of books these are some things I mentioned on the way through. I just put them all on one slide. This topic has been so near and dear to my heart that I actually started a little side project to address it, and I started what I call the Dev Institute, which is just to train people on best practices of software development. So it's really new, but I'm gradually putting more content out there. This briefing will show up in a blog there, so feel free to check it out. Or if you want to learn more about any of these things, just contact me. I'll leave that one up there. Do I have any questions? Oh. Microphone.
One scenario that I've encountered many times in my work is that somebody, either you or your analyst, trying to reuse a previously done projects. And our projects are not really code. Sometimes it's SQL and sometimes it's just Excel. Say, oh yeah, I know, I've done it. They go in and they try to customize it. And it's an endless cycle of frustration of how to get somewhere. And I would always say, if you encounter an issue with it, just do it from scratch. So what is your sense of when is it worth doing from scratch, or when is it worth putting more effort into the original?
I would a lot of times base that on how well documented it is. If there's no documentation, you are really going to struggle. Are the people who did it the first time around to ask questions? Okay.
It was 3 months ago.
How good is your memory? So something that helps with that is just doing your own documentation. I know for me, I really thought my memory was going to be better than it was. And so it's surprising how quickly things are hard to remember. So yeah, just take notes. Document in your code or even in your spreadsheet. You can put notes in there. But
I started doing footnotes for my
One of the suggestions I made for my analysts is put a footnote in the presentation outlining when the data was drawn, what kind of data, and how you used it. It's not for the people who are going to look at the presentation, it's for you, because this is going to come back to you 6 months later, and somebody's going to ask, can you redo it using this data? And you'll be like, I have no idea how I've done it and where it's saved.
Yeah. Thank you. That was a good question.
Hi, I'm wondering if you have a favorite conversion story, someone who started out really not wanting to follow the practices you were advocating for and then became a convert at the end of some period of time.
I think I've seen more like I said, my clients seeing it more. I think they were used to seeing people just kind of come in and just throw code together without thinking about the big picture, and so I don't have any specific people, but I think they have come around on, it is software development. It's not just writing a script.
Yeah, this is a great talk. I actually think this is really important to share with people. I was recently at a conference at UCLA, and it was more like statistical genomics, whatever, and everyone showing some amazing models. And then I just stopped for a second, and it was supposed to be kind of like a course. And I was like, well, this is not a course, is it? Like, everyone's just, showing their research. That's great, it's always great to be a part of that. But at the same time, I would like to see how people are handling these stuff. Like, I feel like we don't have enough conversation about it. And one of them said, oh, well, I wouldn't, even care about other people's code. Or I don't know if I would actually, could respect that because everyone is doing their own thing. I was like, oh my God, this is such a horrible answer. Like, really. But I think this is very valuable, and these kind of things should be out, like, I think even more, now that the data is getting bigger, and we just need to use these tools, no matter what it is, right? So that the Excel is not enough. And my question is actually, not necessarily code maybe, but I'm a PhD student, and I do clean the data a lot. And then I have a bunch of versions of the data. So I'm already using this version control. Of course, I'm a frequent user of the GitHub, and we use it as our team as well. And I love it. It's really valuable. But obviously, the GitHub is not going to work for your data. I'm always wondering how people are handling these versions with their data when they're cleaning, and what part they're actually using for the analysis, training tests or sets, etc. I was wondering if you had any suggestions for that.
We've actually had pretty good luck with Subversion versus Git for data and more static kind of files, but it's not the perfect solution either. So sorry, I don't have the silver bullet for you there.
I was wondering, when you do have resistance to this idea among a team, what techniques have helped with overcoming that resistance? People who just don't buy into documentation.
So code reviews are really good for that. You don't pass the code review until you have the documentation, and we've done a lot of peer code reviews, and there's a lot of pride involved in that, so people want their code to pass the review. Puts a little peer pressure on them. All right, thank you.